Today we're going to look at 8.1.5 and 8.1.7, design, construct, and test a device that can affect the rate of a phase change. How to keep an ice cube from melting. So how to keep that heat energy on the outside in the surroundings, that heat from moving into the ice, so from hot to cold. Heat always moves from hot to cold, high to low. So heat is always trying to spread out, get equal. So heat moves from hot to cold. And heat can move in three ways: conduction, convection, and radiation. But it moves from hot to cold. If we wanted to keep something cold, we do this by keeping the heat out, keeping heat away. We could use some insulators. Insulators prevent heat from moving from one place to another. Examples of insulators. So these are materials that prevent that heat transfer from hot to cold. We have sawdust. Remember, we talked about sawdust and how years ago we didn't have refrigeration as we have today. So they would harvest big blocks of ice from frozen lakes, pack it in sawdust, and it would stay frozen for months. We could use styrofoam, newspaper, wool, fiberglass, air, or straw. Any of these would prevent that heat flow from hot to cold. If we were making a device to keep ice from melting or just to keep food cold, we could make a real simple device. We could make it from wood, even cardboard, which are both insulators themselves, and then line the inside with one of the insulators, or maybe two of the insulators, or we could wrap the frozen material in an insulator. Any of the insulators would keep that heat energy transfer away from the ice. From where it was high on the outside, it isn't going to go into the ice where it's cold. Thank you.